Hello Year 9s, so just a very quick video to accompany your lesson on the atomic number and the mass number for today. So these are two things that are really important in chemistry. They live on the periodic table, so they're specific to each element. So beside, above or below each element on the periodic table, you will see a specific atomic number and a specific mass number to that element. So it's really important. The mass of an element, the atomic number, it tells us a lot about how that particular element behaves in chemistry. So these are really vital things for us to know and really important for us to learn and then to review in future as we continue on with our learning in this unit of chemistry. So represented here by the letter Z down the bottom left-hand corner is the atomic number. That tells us the number of protons. Represented there by the letter A is the mass number. Now that is the number of protons plus the number of neutrons. So very quickly, a review from our last lesson. I know that you have already had a bit of a look into the relative mass of different components of an atom. Just a quick revision of that now here. There are three components. I might actually even type this. There are three components to each atom. So we have protons. Let's pop a little table in here. That might be the best way for us to do it. We have protons, we have neutrons, and we have electrons. So let's insert a row above. Each of these have a charge and they have a relative mass. So we did this in year 8. Protons have a charge of positive charge. Neutrons are neutral, so they have no charge. So we often just represent that with a circle or a 0, and then electrons are our negatively charged component. So we represent that there with a negative symbol or a subtraction symbol. Okay, now an additional part from last lesson. Two of these components have a mass. The relative mass of protons and neutrons is 1. Electrons have virtually no relative mass, so we represent that with a 0. Now what that means is electrons are virtually weightless in the eyes of our elements. So they whiz around the outside in their electron shells or in their orbitals, and they don't contribute any weight to that atom. However, protons and neutrons do have a relative mass, the same, it being 1. So now we can get back to our little components, or our A, our mass number, represented over here in our little graphic on the left. So the mass number is represented there by the A. It's the number of protons and the number of neutrons. The atomic number tells us the number of protons. So if we were to work this for an element, let's say carbon. Carbon is the 6th element on our periodic table. It has an atomic number of 6, meaning that carbon has 6 protons. It has a mass number of 12, meaning that when you add the number of protons and the number of neutrons together, you get 12. So, how does that look for us with this carbon? We know that protons, the atomic number down there is 6, so we have 6 protons. The mass number is 12, and that's our number of protons plus our number of neutrons. So if our number of protons is 6, to get to 12, our number of neutrons must also be 6. And very lastly, our electron. So at the moment, we're working with a neutrally charged carbon, and at this level of our science in grade 9, we're not talking about ions just as yet. So I need to figure out how many electrons do I need to counteract that positive charge of 6. If I've got plus 6, and I want to get to a neutral charge of 0, how many negatives do I need? So if I've got 6 protons, for every electron, that's 1 negative charge that cancels out one of those positives. So here we go, 1 for 1, a negative charge, a negative charge, a negative charge. We've taken care of those 3 positives. A negative charge, a negative charge, a negative charge. We've taken care of these. So now we've got 6 positives paired with 6 negative charges. We end up with the relative charge of 0. It just means that our atom is neutral. We needed 6 electrons here. So in our carbon atom, we've got 6 protons, 6 neutrons, and 6 electrons. Quite commonly, you'll find that these 3 numbers are the same, but it's not always the case. So that's why we have to practice this way of working while we're just learning this component of chemistry. We can now draw that. So I know you also reviewed atomic models last lesson. Let's have a go at drawing this carbon atom. So, our carbon atom, I started there with 2 electron shells. Let's draw that a little bit neater. So, started there with 2 electron shells. Those electron shells are where our electrons are going to live. In the nucleus of our element are our protons and our neutrons. We know from our working that we have 6 of each. This is very tiny for that pen, but that's okay. We're getting there, we're doing it. And our neutrons, I'm just going to represent with a brown circle. This is art, people. I'm telling you. You've never seen anything like it, I'm quite sure. So there's our protons and our neutrons in the nucleus of our atom. Our electrons, we have 2 that occupy that first shell, and we know that our carbon atoms have 6 all together. So we've got 1, 2. Let's place our remaining 4 around the outside, evenly around that last electron shell. So while that may be the worst drawing of an atom that you've ever seen, it is in fact a carbon. So we had 6 neutrons in the center there, 6 protons. Now we were able to work that out from our mass number highlighted in blue there. Around the outside, we've got 6 electrons. 2 in our first electron shell, 4 in the second electron shell.